Dear colleagues, you are welcomed at the National University Zaporizhzhia Polytechnic, the International Webinar on Remote Laboratories. This event is prepared for you by the Department of Software Tools with our partners from Portugal and Mexico, and we have such agenda for this event, as you can see on the slide. First of all, we will give the word to our partners who present their ideas and possibilities on cooperation, and then each of our departments who want to speak about their needs or their proposals or their interests in possible cooperation can present but shortly their results, and we will have a discussion on possible cooperation in free mode. So I give the possibility to our colleagues to present their proposal, and we have today Professor Alves from Portugal and Professor Garcia from the Mexico. So please, who will start? You have your rights.
First of all, I believe this webinar could have been delivered sooner than this. Last month I went to Mexico, where I visited my colleague Manuel Macias, and when he was presenting his remote labs, and due to the time difference between Portugal and Mexico, which is 6 hours, and by the way, this will be 8 hours between Mexico and Ukraine, I thought there's an opportunity for cooperation that I believe will be interesting for our colleagues in Zaporizhzhia. We have received and we have some long-term relations with Sergey and Galina who were from initial, or in this case, Galina was original from Zaporizhzhia. And so it's not that everything came down and I said, oh, I need to do this. What we will do is to show two different types of remote labs. One that allows several users at the same time. So you can use this with large classes with tens and hundreds of students. And the other is a remote lab, or a series of remote labs that will be presented by my colleague, Manuel Macias, that only allow one person at a time. If you want to allow more persons, then you need to replicate the remote lab. But the whole idea is that at the end of this webinar, we some way engage on collaboration, okay? As a user and later on as a developer. So we want to show how you can develop, how you can produce your own remote laboratories. And we'll see from here where we can go, okay? So the first remote labs I will present are the ones that allow several users at a time. I will put the link on the chat window, okay? And you can use this link to access this remote lab at the same time that I will be accessing it, okay? And we run 1 or 2 experiments, okay? You see what you can do, and later either you use it or you can invite other colleagues from Zaporizhzhia to use it. The whole idea is to allow students and allow people to do more experiments with real components, with real circuits. That's the difference between a remote laboratory and a simulation. On a simulation, you run code. It's just code being executed. On a remote lab, you access real equipment and do real experiments, okay? So I'll put this on the chat window. If you follow this link, you can register yourself, okay? And you will end up in a window that I will open right now. I believe I can share things with you. Let me see. Yep, I can share this with you. Okay.
We see your screen.
Yep.
Okay.
And you should be seeing right now this one, right?
Yes, maybe. Enter.
If
Enter. Uh-huh.
Okay, you register yourself with that link.
Mm-hmm.
If not, I can pass on the control to you, and you share your screen with me, and I will guide you in the process. Whoever is taking whoever is trying to access. So if you want to try yours, or Volodymyr, anyone, just share your screen, and I can see what
Does
you are
somebody
seeing.
want to try?
Sergey Alexandrovich, you can try.
I will try, but my speed of my computer maybe don't be possible to support Zoom and this at one time.
It's a real case scenario, so how it goes.
So what should we do?
I need to show my screen. So I need to
It is my first time.
log
It is my
in,
first
да?
time. Yeah, it is
Log
my
in.
first time. No. Try
It's
the
not
blue. Yeah. Okay.
first time. What's
Yep.
it? This one.
Yep.
Mhm.
Okay. And
Mhm.
a password with us.
It's Cyrillic. Um, so
Okay.
it proposes me to access this lab. Electronics
Access.
5.
Yep. Okay. Access.
Access. Directing. So I'm inside something like laboratory.
Yep. It's the connection speed is not that great, but you start to see something. Okay.
So we have images from the web camera, as I understand.
Yep. Okay. So what I'll do is I will ask you to give me the share possibility again, and I will show exactly this very same lab. What I wanted to do is to show that you can register yourself.
I need to give you a screen.
Yep. Okay.
Okay. You have right.
Okay. Share, and then I'll leave this one. I'll go to this one and log in. Okay, and we go to here and access this lab. Access. Okay, so this lab is for basic electrical and electronic circuits. Okay, so what you can do is the following. It gives you access to a breadboard and to the very basic instruments that you can use in any lab for electrical circuits: a multimeter, a function generator, an oscilloscope, and a power supply. You can see this plus sign here. This will give you access to the store of the components. So let me use, for instance, a 1K resistor, a 10K resistor, a 1 microfarad capacitor, and 2 diodes. Okay, so these are there are many more components. Not all of them are installed in the remote lab because this is a remote laboratory and it has a limited capacity. But these are components that are fairly common and that we have installed now. So let me just make an experiment, very simple one. I will rectify a sine wave just to give you an idea of what students can do. And by the way, you can do the same experiment as I am doing. What happens is every time I do this perform measurement, okay, this button here on the right bottom corner, the description of the circuit will be sent to the remote laboratory. The circuit will be mounted. The signals will be applied to the circuit, and the responses will be sent to your screen, meaning a real experiment is made whenever you press this button. So, for instance, let me put a diode here. This is straightforward, okay? I think whoever teaches electrical circuits must have used this kind of breadboard. This is universal. I will use the 10K resistor, and I'm going to use the capacitor, so that I have to have a filtration of the wave. I select a wire. I have to click on one of the colors, and then I have to click on the first point, and when I have the wire on its intended connection, I just leave it, okay? And it's connecting from the function generator to the anode of the diode. Let me close the circuit here. And by the way, you can bend the wire like this. If you click on the wire and on this middle point, you can bend the wire. And another connection. And then I will connect this to channel 1. It's not right there. Now it is. Channel 1 will see the input of coming from the function generator, and channel 2 will see the waveform at the resistor. Okay. If you click on function generator, you can configure it. So frequency is 1 kilohertz. Amplitude, let me put something like 3 volts. Okay. And the oscilloscope, the 2 channels are lighted. When I press this perform measurement, the description of the circuit will be sent to the remote lab. Generally, it will be sent here to Porto, but what happens with the IVE laboratory is that there are several of these laboratories installed all over the world. So it may be the case that the experiment will be done not here, but in Germany or in Costa Rica, where there are other similar labs like this. So there is a federated connection of all these the remote laboratories, okay? Let me perform, and I have here the result, okay? So you can see, for instance, the result. So you see the way. If I change something here, you can see the rectified. For instance, if I go to the breadboard and I take out the capacitor, okay? You'll see just the rectification without the filtering, okay? Or for instance, if you put the capacitor back.
May I add something?
Yep. No.
I need to emphasize that it is not a simulation. Those are not virtual values, virtual measurement. There are real measurement that mean when you select the diode or the resistance, you are going to select physically one of these components and you are going to connect them really in a equipment that is in Porto or as Professor Alves say, in Germany, wherever, but it's something that is really happen at this moment.
The thing is that several people can access at the same time. The experiment is done in something like 1 second. So if you have several students doing this at the same time, not all of them are going to click perform experiment at the same time. So this allows you to give a class to students by Zoom, presentially, and they can do their own experiments while you are showing. So they can test. This is good because if they have a problem, they share the screen with you and you can help saying, oh, you have not connected here, or this is the configuration, oscilloscope, etc. Everybody has access to the remote lab at the same time. And this allows you to do experiments and allow the students to learn from the experiments. And they can try on their own later on, okay? So I just wanted to share this with you. You have the access. While you have access, you can also share this with your students. But the whole idea is bringing the lab back to the central part of education. I think students learn better doing experiments, and remote labs allow you to do this either, in a Zoom or in a class, whatever, okay? So I conclude my part here, and I will pass over to Professor Manuel Macias, who will show you another style of remote labs where you have to book, because only one person can access at a given time. You can replicate, but Manuel, it's your turn. Thank you.
Yeah, thank you. As you saw, there is a really nice tool to have some kind of basic course like instrumentation as well, no? Our electric circuits or electronic circuits with real equipment. Right now, let me share my screen. This here. Yeah. Are you see right now my screen? Yeah. Yeah. Okay. Okay. I'm going to go very quickly in a short presentation. Yeah. Of course, the main idea is the remote labs platforms. Yeah. Was Professor Alves already described, but it is really nice for me. Right now we are in 3 different parts of the world. Yeah. We are in Portugal, and we are working on showing you the remote labs that are in Mexico. Yeah, the 3 parts of the world are we present right now. I cannot. Okay. The problem behind that is, you already know, a theoretical course is quite easy to have online, to teach online an electronic course or electric circuits. The theory is quite easy with tools like this one, Zoom. I was during the pandemic with Zoom for 2 semesters, really in a good way, teaching electric circuit and everything, this kind of courses. But you know exactly that the labs, the practical skills that we have to develop for our engineers, future engineers, are very difficult. That is the main idea, to have this kind of platform that allow us not only to transmit the knowledge, but to apply the knowledge, something that for the engineering is, of course, really, really important. The idea is to have some kind of platforms for access the physical resources from the laboratory at any time, from any part of the world, really from any part of the world. Of course, you already know about different problems, not only the problem that you already right now have or that we have during the pandemic, but another problems like the cost of the equipment, the space for the labs, or the assistant that have to be in charge of the lab. But of course, the last two of them are right now for us the more important, no? The ability outside of the office hours, but also to be able to access the labs outside the campus. Of course, the most important thing. There are two main objectives right now for us. One of them, it is to allow the students, like Professor Alves say, with this platform, the Hive platform, you can really give the access to the students so that they can work on their experiments. At the same time, maybe with the professor during the class, or outside the class, outside the campus, yeah, from home. And the second part, it is allow the professor to bring the lab to the seminar room, I mean to the class in Zoom, yeah, so that they can do really experiments, I will say maybe advanced experiments during the class in order to show the physical phenomena that depend of the electrical circuit, the electronic circuit, or electrical machines, power electronic, whatever, control, automation, whatever you want to teach, yeah? Of course, there are another objective, but right now it is not important for us. Usually we have different parts for our remote labs. Website with information about the course, a scheduling system in order to control the access for every user and also the time for the user. By the way, in this case, we give, for example, an access, a password and a user for professors in order to use the lab, to show the experiments, to work with the real experiments during the class. And of course, we have to have an interface in order to work with the components like Professor Alves already showed you. And sometimes we need also an audio and video system in order to see and hear what is happening there in the lab. Sometimes there are electrical machines or maybe an automation system. I need to be aware what is happening there. Yeah, you know, that is really important for us as engineering when we are on the plant. Nah? There are different kind of remote labs, we call of them platforms, remote labs for instrumentation, electronics, exactly, or more or less the same that Professor Alves showed you. For us, there are only one station for everyone, but if we need to cover more students, we only reply the stations. Of course, a little bit expensive, but I will say the basic labs like electrical instrumentation, electric circuits, electronic are low-cost platforms. Yeah, I will say low-cost platforms around maybe $4,000 until $5,000 euros every platform. With one platform, I can support around 100 students per week. Also, 2-3 courses, groups, students. For the automation, control, and power electronics, those are, for me, a little more complex platforms, more complex equipment that it is a little bit more expensive and is difficult to simple reply. Let me show very quickly for instrumentation, DC and AC, electric circuits, electronics, different levels of electronic for filters, for example, oscillators, etc. Automations, yeah, remote lab for automation, for industrial network, that means distributed automation, for a power system, more power system, for system control, for example, robotics, more robotics, power electronics, again, one more, electric machines, yeah. All of them are maybe more and more advanced. For example, for remote electric machines, it is an advanced remote lab that we don't give the access for students, but only for processors, because the kinds of experiments that you can do there. Okay, that is very simple and image of the impact that we have, for example, in Mexico with different students, with one remote lab, one experiment from north from Mexico to the south from Mexico. You can imagine what can we reach the amount of students, the amount of professor or region that we can reach. We transfer already some platforms for our college in China, Hangzhou Densi University. They have already built a huge remote center lab with 40 stations, as you see, 20 stations for analog electronic and 6 for power system, etc. But let me show you right now exactly one of the remote labs. I'm going to click here, very simple, an application to go to one lab, DC-DC converter, a basic experiment for power electronic. Yeah, of course, you, what happened here? I don't see the, it's behind maybe. Maybe it's behind, or? No, right now it's here. Right now it's here, okay. You are seeing, yeah? Yeah, okay.
It's not showing.
Yeah, yeah?
No.
No? Oh, why not? Let me see. I'm going to stop the share and share again. I don't know why you are not seeing that. It's because, okay.
When you share, you have to select what you want to share.
The entire screen. Let me see. Share screen. Now? You are seeing that? No.
Wait a minute, give it.
Okay, we see.
Now. Okay, now. Okay. I'm going to log in, for example. Let me see. Okay, that is the account and the password. I'm going to see here for example, for a speed control of a DC motor to apply the CD converter for a DC motor. Of course, it is not a closed loop control, but an open loop control. In order to remember, right now, the idea is to analyze, for example, the DC conversion or the trigger of the transistor, for example, yeah, the amount of charge, the amount of power, energy. As I said, sometimes we need a audio and video system in order to see what is happening there. Yeah, we have here down the oscilloscope, a kind of oscilloscope. For us, it's very important. Not a commercial oscilloscope, but something very easy to use, so that the student or the professor is not going to focus on the oscilloscope. Right now, it is not the idea to learn how to use the oscilloscope, but to learn about DC-DC converter. Also, I only need to click here to see the voltage for the motor, or maybe the control signal for the PWM. Yeah, I'm going to turn on, for example, for the positive voltage or negative maybe, and I'm going to turn on the control signal. As you see right now, you are seeing here the pulse rate modulation signal that I'm using for the DC source, and the voltage for the DC motor. And it is really nice for me. Look, there is different, parameters or information that we can discuss with the students. For example, that is exactly the time I'm going to put the modulation. That is exactly the time that I'm turning on the transistor, and that is exactly the time that I'm turning on the transistor. I can see on the DC motor the time that is on, and then I can see here the time that is off, but there is still current. That's why there is a minus voltage, because the current is still running. I already saw that the signal for the current, it has an error, yeah? It is 0. I'm not measuring right now the current. Also, it is a problem, but I can see here, look, that is really, for me, really nice. Here, the current is already off because of the time of the modulation. It's already off. And I can see the induction voltage for the DC motor, yeah? Only this inner value for the induction that is inside the motor. Sometimes it is not very easy to do it. We can right now really talk the voltage in order to see what is the CAFE constant for exactly for this motor. Of course, we can, let me go by and increase maybe, you see the PWM, increase maybe the speed, yeah? And we have a signal, you see the increase of the induction voltage, of course, because of this increase of the speed. Let's go very quickly outside and go also very quickly, as you see, in less than 1 second, we can change from one lab to other, yeah? Well, maybe 1.5 seconds, yeah? Right now, let me log in, wait. Right now, for maybe a phase control converter or symmetrical angle converter, let's say the simple phase control for a AC converter. Sorry, it is in Spanish there. It is an error, okay? AC converter. And right now, it is not, there are not transistor or IGBTs, but thyristor or triacs, and different kind of power semiconductor devices. In this case, of course, we always need to have the audio and video system in order to see what is happening. And we are going to turn on the control, and we are going to control, for example, the timing for the turn on of the triac. As you hear on the control signal, let me pause this, yeah? That is exactly the time that I'm turning on, and you see here down exactly what is happening with the voltage and the current. By the way, this is the green one. It is the voltage for the source, this source that you have in every lab. There are 100. There is in America, in Mexico, we have 220 volts, effective volts. Also, it will be 170 volts, the amplitude. That is the span that we have, not the 220 volts effective. Yeah. Also, you can see exactly what is happening. For example, if I increase or change the time for the impulse that I'm going to turn on the thyristor or the triac in this case. Also, there are a lot of things that I, as professor, can discuss, can show, can analyze during the classroom. For me, the main idea it is that the students really understand the relationships between the theory, the mathematical concept, and the physical phenomenon. And they can see what is really happened when I change the time, when I change the voltage, etc. Also, I'm only going to show one or two. This one for basic power electronic. Let me turn this off. Let's go out. And again, in less than 1 second, we're going to go to another remote lab. In this case for, let me see, for electric power transmissions. Yeah. Again, by the way, the other platform, I will say it is a low-cost platform. You see, it was a video without audio. We can put the audio, but I don't think it was necessary. For me, was the low cost. Also, there is a simple webcam that you are using there for this lab. In this case, for transmission line, power transmission line, it is quite complexer. Also, I need a better system for video, audio, etc. If it is at night, it doesn't matter. Maybe it is midnight for you, and a day, I don't know what happened. Let me see. Yeah, I'm going to turn out the light exactly. It happened. We can connect to the lab, turn on the light, and then begin to work. Right now, that is the setup for the power line, an emulation, a physical emulation of the power line. There are some commercial instruments in the top part. I'm going to turn on these instruments in order to have it available. Yeah, and we have also left down. I'm going to show you right now a three-phase system also, so that we can really play with the three-phase system in order to define whatever you want. If you want to change the voltage, the amplitude, of course, if you want to change the phase of the three-phase system, if you want to change the frequency, again, wherever you want. I'm going to turn on the power. I hope, yeah, now it's on. I'm going to define, for example, here, not 60 hertz, maybe like in Portugal, or I don't know, in Ukraine, 50 hertz, not 60. I'm going to define here the voltage. Maybe I'm going to give 60 volts. And right now, we are seeing what is happening. Let me show you, for example, on the source side, that is the three-phase system that I right now put in there on my experiment, and I can see the three-phase system that is already on the load. Yeah. Also, you can see maybe the voltage. I put only one because if I put everything, then it is quite difficult to see. Current or voltage on the source, on the load, or maybe say, okay, I'm going to see only the voltage and the current for one phase. It is really nice. Why? Because the load right now, it is a simple lamp. Also, a resistant load, of course, should be a phase of, there is not phase, the phase is zero right now between voltage and spanum. But if you see the same phase on the source side, there is a phase delay between both of them. Why? Because of the transmission line. And at that time, you have to analyze what is happening. What is happening with this phase? Why? It depending on the frequency, we are going to change right now the frequency. I'm going to put 30 hertz, and you are going to see exactly. Okay, you have to measure that in order to see. Let me put here 100 hertz. Yeah, and we have, you see there is a bigger delay between the voltage and the current. Yeah, because of the frequency, and you have to analyze everything that you have to to see with your students, for example, the power that you are going to lose on the line, the energy, reactive energy that is going to be remain there on the line, everything that the power factor that we are going to have, for example, for this system, and of course you can do everything that here, but you can also simple go to the this measure instrument, and if you don't want to do all the process, only to see the measure. Of course, there is these measures are here, measurements are here also on the interface, But if you don't think that those are correct, you can go to the commercial measurement in order to see also both of them are real. Both of them are real. Maybe it is a kind of difference. Of course, there is a. If you put an multimeter there, it will be also a little bit different. Also, that is the real world. So is that. Of course, there are a lot of things that we can do. For example, to analyze on the time domain, or maybe I don't know, there is a phasor domain. I don't know if there is a phasor domain, but to analyze the behavior of the phasor, or maybe the power. At this moment, I'm going to destroy my balanced three-phase system. I'm going to select, for example, for the phase C, and say, the phase C is not going to have 120 grade the phase, but let's see, 90 degrees. And after that, you see what is happening in my three-phase system. Maybe you can see here the phase representation. As you see, the phase B, it is 90 degree the phase. For the time, in the time domain, it is quite difficult to see that. It is not very easy to see that. But you can have different kind of tools to analyze the behavior. We don't think that is necessary right now, for example, a frequency analysis or something like that. Let me turn out everything that. I go outside, and again, give me 1 minute more or 3 minutes more in order to go in 1 second more to another remote lab. Right now, it is working, not 100%, but it's working. I like it very much. This one, it is one of the remote labs that we transferred to China for electric machines. Again, you see from the other remote lab, when you go out, the system, I didn't turn out the light. The system is going to turn out the power supply. If I let it on, it's going to turn off the light. Whatever you need is going to be turned off, so that it is not remain on. Also, we come back on. You see there the other lab. Those are in the same room, But one is electric machines, the other is power system. Those are the electric machine. We have also a power supply there. You see here the power supply, a different one. I had a small with the power supply, so that I had to right now to disconnect the motor, but we can see the interface on what can we do. You see, right now we have a three-phase system with 120 volts at 30 hertz, 30 hertz, but the motor, it is disconnected, so that avoid to have right now some problems. Let me see, induction motor, this is the induction motor, and you can see here on the left, you are going to set up the parameters of the induction motor that you are using right now, yeah? And then you can go to the time domain in order to see exactly like before, all the parameters that you need to measure for the three-phase system in the time domain, or maybe to the frequency domain in order to see, for example, for the phase A of the voltage or phase B or C, whatever you want. As I say, right now the current, it is not there because it is disconnected, but or the phasor also, the phasor, in this case, you can see exactly, if you have the current, you can see if the motor is correct balance, yeah? If you see the current, maybe a vectors analysis, yeah? In a vector, in a complex domain, let's see, yeah? Of course, as you see here is interesting because the voltage and the flux, yeah, flux, the campo, flux, yeah, the flux, there are in 90 degrees, something that is not correct. That's why, because the current right now is zero. Also, the phase between the flux and the vector for the voltage are exactly 90 degrees. That is the one of you that is in electric, not well, electric machine and control. Yeah, they know that. Yeah. Of course, we can here a power analysis right now is zero. Torque is also only noise. The vibration for the system, and also a thermographic analysis for the complete system. In this case, for us, it's important exactly the motor. Also, we can see exactly what is happening in the motor. As you see, for example, I want to see here, this is 26 degrees, maybe the motor is 24 degrees. It's okay. It is cold. It is not working right now. No? Everything is fine. Also, but that is not all. The most important for me, that is right now, unfortunately, is not working because it's not connected. The motor, yeah. You know, that's why it's come right now the error when I try to use this one, yeah. Because right now here with this small app, I can play again with the three-phase system in order to do different kind of waveforms, to apply different kind of waveforms to the motor in order to see what is happening if I have an harmonic, for example, a third harmonic or a second harmonic, or I don't know, whatever I want to analyze on my electric machines. Also, that is the idea. Right now, we had an error. I have to go out now. Yeah. And I hope you can see, of course, you know that, but to see exactly what we can do for the students, for instructor, for institutions, and also for the government, I mean, for the countries, yeah, to give the possibility to cover small and very remote locations. Yeah, that is our main idea. Of course, you see that from any time, at any time, you see where I'm using the remote lab, exactly the same remote lab that we were showing right now, yeah? But, oh, wait, I have to show you this one, because I always say the limit is not the world. You see that, this remote lab? You can see where I am working. You see? Also, the limit is not the world, the limit is the sky. Wherever you are, if you have an internet connection, you are going to work on your experiment, on your lab, on your equipment. Yeah. Okay, that is not necessary. Okay. That's where. That is all. Okay.
It's all as a presentation.
Yeah. That's what.
Thank you very much. It's very interesting and fantastic because such opportunities to use a lot of different installations. I think that our colleagues from electrical engineering departments, from different departments related to computer science and automation will be very interested in possible collaboration and for using such laboratories. If you have a time, I want to give some words to our colleagues from our departments to present themselves and to speak about their needs. Maybe you will be interested in possible cooperation and collaboration. So our representatives who want to say something about themselves. Generally, you are familiarized with our Faculty of Computer Science and Technologies because we have a partnership on the basis of a Department of Software Tools, where we have a first in the university laboratory of embedded systems and remote engineering with several installations, and also we have access to a Goldie network of laboratories with German and other universities. But your installations are very interesting for me. I was very impressed because you have not only installations and usual camera, but also a remotely controlled thermal imager. It's like fantastic. So fantastic. So it's very good opportunity to use such installations. So our colleagues from National University Zaporizhzhia Polytechnic, who will be the first to represent yourself? Please take your word. Maybe if somebody want to make order, maybe you raise your hand or something like this.
Let me start.
Yes, please.
Hello, colleagues. My name is Natalia Furmanova. I am Dean of the Faculty of Information Security and Electronic Communications at Zaporizhzhia Polytechnic National University. At our faculty, we train specialists in electrocommunications and radio engineering, as well as automation, computer-integrated technologies, and robotics. Our educational programs focus on modern electronics, embedded systems, automation in different directions, and digital technologies. Currently, we are very interested in creating modern laboratory with remote access, and I think your proposition, your offer is very interesting for us, for our students, because they're big part of our students now aren't in Zaporizhzhia, and the remote access to your laboratory is interesting, and it can be very useful for our students and us too. And we have different educational components in our educational programs about FPGA, about computer electronics, about scheme techniques and other technical disciplines. And there we use different simulation systems like multi-sim or maybe Tinkercad, but as I can see from your presentation, you have not simulation but real remote control system for educational purposes. So we are very interested in our future communications, and I will send you a message about our possibilities and our interest in this direction. ask we can see about our future ideas. Maybe we want to create our own remote laboratory for with different stands, with FPGA, with microcontrollers, with different automation systems for industrial electronics, industrial enterprises, and so on. So we have some ideas, some documents which were given to some projects, but now we haven't financial possibility for creating this laboratory. But I think European and Ukrainian science have many ideas for future, and we can do it together. Thank you.
Thank you very much. I think that it is good. Your current presentation was very interesting, as my opinion, for this faculty, because their mainstream is electronics. So such a big different installations, it's good opportunity to involve students in such experiments. Some people write in the chat, so Professor Alves, as I see, read and answer. So we will give word to another people who want to say something. Please, who want to be next? Somebody other departments want to say something?
Could I ask something about this installation? I'm from this faculty, Olga Vasilenko. Nice to meet you. I was once to Porto. It's a very nice and pleasant city, by the way. But if I got it right, you have like the list, like a pile of installation all around the world. But how do you provide installation on the Porto board? I didn't get it. So the Porto board, so by what means, who, or it's a mechatronical system or robotic, how? It's like magic for me.
Olga, thanks for your question. Basically, it's a matrix, a programmable matrix with relays. So whenever you send the description of the circuit to the remote lab that's here in Porto, these relays are connected. The components are pre-installed there, and they are connected to the measurement instruments. Okay, so the secret is a programmable matrix with relays. So the circuit is really mounted, and you get real measurements of that. I can go into the detail to show you reflection lines, things like that, capacitive effects. But the whole idea is, yes, this is done through a programmable matrix that connects the components. Did I answer to your question, Olga?
Yes, I got it. Thank you.
Thank you very much. Who will be the next?
Yeah, I only will say a huge amount of relays that in this case, Professor Alves have in the system, yeah? I have to say, in our case, you saw, Olga, there is not so kind of selection of the component. We change the component, yeah. That means that I only need 4, 5, 6, 10 relays at most, no more. But it's the same process.
Okay, thank you. Does anybody other want to say something? Maybe electrical engineering department something want to say, because they have a lot of departments related to electrical machines and installation, power transmission, etc.
Hello to everyone. Is it okay with our sound? Can you hear me clearly? Is it okay? Okay. So just a few words about our faculty. So we represent an electrical engineering faculty. Here with us, our dean, Nicola Antonov, of the electrical engineering faculty. And our faculty consists of the 5 departments. Power supply of industrial enterprises department, electrical machines department, electric drive and commercial plant automation department, electrical and electronic devices, and one more, but it's not the department that graduates students, it's department of physics. Here with us, and Andrei Perezhok, he is the head of the electric drive and commercial department, and 2 associate professor from this from electric drive and commercial department. So first of all, thank you very much for this presentation, for this information about the remote laboratories. For today, it's definitely actual and relevant topic, and it is very important, especially in our conditions. But we have some questions about the first is it possible to find some methodical guides or some descriptions of this laboratory to investigate more in more detailed way? Because right now we listen this information, but we want to investigate it more in more detail. And other question is about the procedure of joining to this laboratory. So the price, the rules, and so on. So how we can have an access to these laboratories, what the rules, what the conditions, and so on. Yeah, is it necessary to have some kind of agreement between the university and so on? So, yeah.
Well, first of all, thanks for your question. Let me say this. As I put it, you can access the IVE remote lab right now. I mean, because there is no limit on the number of students that you can have at the same time. For me, it's no problem, okay? And basically, these are electronic components and electric components, so the chance of doing some damage to the components is very low, okay? So you can use. But the real thing will be for you to have one of these remote labs there, because then it will be part of a network. There is a company called Labsland that sells these remote labs, okay? The IVE one. And this will cost you in between around, let me say 25,000 euros. It is sold in redundance. I mean, when you buy two are dispatched to you, so there is a redundancy, okay? This allows you to change components in one of the remote lab while the other is still alive, is still online, okay? And the other thing is that when you connect your IVE system to the network, it will be connected to the Federation of IVE remote labs. This means that part of the experiments that you have on your site will be the same as on other, so there is redundancy, and some will be just for you, okay? So this is the concept of a federation of remote laboratories, okay? So that we can enlarge, serve more students. And by the way, when you do an experiment, you can be doing an experiment in Porto, in Costa Rica, or in Germany, because they have IVE systems there. That's why I'm not afraid of sharing the remote lab with you, because there are many remote labs to be shared, okay? But the real thing will be to actually find some financing for you to acquire. In the past, we have installed 5 remote labs of this, the Visir one, in Latin America, because we had an Erasmus Plus project. If we find the right program, I think we can apply for that. But it's not just about the installation. So the remote lab is one detail. What you are going to do with that, how it will serve your university, how students will better learn with this remote lab, etc. That's the main purpose. And I think in the case of the current situation of the Ukraine, you can actually make the point that remote labs allow the students to acquire vital experimental skills that don't require the student to go physically into this building, into this place. The students can be here, the teacher can be there, but all of them are doing real experiments and cooperating, okay? But we can later on exchange emails. The main point is, let's look for a program, let's look for financing, whatever. But the whole idea is to use and install. I think the benefit for your institution will be to have your own remote labs, okay? And maybe you can also share this with other institutions in Ukraine, is to create different networks, an international network, a local network, a regional network, cooperation based on real equipment.
Yeah, let me say in the other side, the remote lab, for example, that I presented, it is also the idea, maybe as Professor Alves already did, it is to allow you to use the platform that he has here in Porto, or maybe the platform from Costa Rica, as he said. But in the case of me, the remote platform from Tec de Monterrey, Mexico, it is a little bit different to allow the professors to have the lab in order to use that for the teaching, for the seminars, for the classroom, yeah? But that is in the short term. That means, in the short term. But in the main term, in the middle term, or I don't want to say long term, in the middle term, it is to help you, to support you in order to develop, as Professor Alves said, your own remote labs. It can be the Hive, as Professor Alves again said, but it can be, for example, the platform that I showed you. I told already this basic remote lab for power electronic, DC converter, AC converter. There is more experiment that you can build around that. It is built on national instrument equipment called Elvis. One set of Elvis had all the instrument, all the data acquisition cards that you need, and all the control that you need. You need only to put the electronic circuits, the power electronic circuits, or the electric circuit that you are going to use. That's why I say it will be around, I will say, between 2,500 and 3,000, the cost of one remote station. Yeah? Okay, wait. No. I say that is the cost of the instrument, the system, data acquisition and control, plus the computer. Okay, the computer, 1,500, I don't know, something like that. Nah? I will say at the end, 4,000, between 4,000, maybe 5,000, depending of the component that I need, yeah, for this kind of remote lab. If you want for electric machines, for example, what I showed you, or power light system, it is different because of the machines, because of the hardware, nah? But it is the same, an acquisition system, the computer, and then what I'm going to use, yeah? For example, for electric machines, I use electric machines for De Lorenzo. De Lorenzo is a company in Italy. It is quite cheap, the machines. Also, it is not so expensive to have one lab like this one, yeah? But again, for us, I would like to emphasize, we will be very happy, really, in order to work with you. And for me, the main idea for the future is to support you, to help you in order to develop the stations, the remote station, your own remote station, the same way that we already did it in China.
Okay, thank you very much for your answer. Generally, I think that electricals and electrical engineering are very interested in such opportunities to use such laboratories. And the next word I want to give to our Vice Dean of our faculty, Sergey Lyoshenko. Please.
Yeah, greetings. I want to represent our faculty too. Professor Sergey Supot and start to speak about it. With the Faculty of Computer Science and Technologies, we have three departments. First department, the Department of the Software Tools, and we have two specialties, is software engineering and the computer science. The second department is the Department of Computer Systems and Networks, and they have the specialty of computer engineer. And the third, the last but not least department, is the Department of System Analysis. We have some background of working with such technologies, and we will be glad to work with you in the future. Yeah, thank you.
Maybe for our faculty is more interesting not to use specific installation, but to study protocols of communication, data processing, programming, etc. So we can, how to say, make a complex view on the remote laboratories, not only to use the existing installations, but also to create new, to work with them, to how to control, so and so on. Maybe somebody other want to say something? Nobody of other departments want to say? Okay.
Let me, please.
Please.
First of all, thank you very much for your presentation, Mikhail Brykov, Physical and Engineering Department, and Welding Department. We deal with the welding of metallic materials, and in this scope we would be interested in your laboratories to study electric matters for welding equipment. It would be very useful to use these distant laboratories, remote laboratories. But we also study the microstructure and properties of metallic materials, and we would like to know if is it possible to use your laboratories to perform, for example, microstructure investigation with some microscopes, or maybe with scanning electron microscope, and so on.
Generally, they have I can, how to say, reformulate the question. Maybe you have some installations or some stands to make experiments with mechanical engineering, physical engineering, maybe welding, maybe metallurgy, and so on. Maybe you say some words about such possibilities.
Yeah. Sergey, let me just answer to this colleague from the welding department. Some years ago, we made a remote lab where we provided real-time access to a microscopic electronic microscope. So that means that you had to use a booking system similar to what Manuel showed. You send the samples of what you wanted to see to the department. At that time, a technician will place the sample you sent in the microscope, and then you could do your investigation. Zoom here, zoom there, you know, use the electronic microscope remotely, but with your sample. This requires some synchronization, okay? Because you need to send the sample, technician has to be there, etc. But again, it's the same thing. You don't have to go next to the microscope, because everything, the microscope is controlled by your computer. So you just provide that access to the microscope remotely, but with your sample. I mean, there are many different things, but as I wrote it down, the whole idea is real-time access to real equipment, and in your case, with your own samples, with the sample of welding or something. Okay?
Thank you. It is
Yeah, if I see, if you allow
very
me to,
useful.
yeah, if you allow me to tell me also something, I was thinking when you were speaking about that, this idea immediately. I think the remote labs, exactly what we have, we can change, of course, we have to work on that, but we can change the kind of, we say, physical equipment or physical phenomenon that you have there. I think every analysis right now will be with digital variables. No? It doesn't matter if you are with vibrations for mechanic or resistance or mechanical resistance, whatever, you are going to convert always on a digital value. Also, the digital value can be the speed, can be the voltage, the current, the vibration, whatever. No? I think the system, like we have, it can be adapted. I will say, quite easy for different equipment, for different phenomenon. It means if it is audio, if it is video, if it is an electrical signal, every sensor right now is going to convert the physical variable to a digital value. Also, it is, I will say, quite simple. When I say also, I have to say, when I say that we can work together in order to develop different platforms, it is not exactly to replay what we have, but maybe to build another one for mechanic or for chemie, whatever. No? That's also the idea.
Thank you very much. Thank you.
Generally, it's a good opportunity to make available in the, how to say, for different universities their to address their needs from one point of view, and for others to develop remote access to their equipment. But for us, it's maybe interesting. Do you have real cases in area of material science, in area of mechanical engineering, and so on, for the remote laboratories, or it's only general possibilities?
Sergey, for materials, we don't have any remote lab here at ISEP for the moment. No.
Mm-hmm. So, dear colleagues, if somebody want to add something or to say something, you have opportunity. No, nobody wants. So all who was interested to say something, they have such possibility. I'm very thankful for all our participants for their interest. I hope that this webinar will be something like starting impulse to how to say establish cooperation, collaboration, and their interest to remote laboratories in our university. Please, you want to say something?
Yeah. Only, okay, please, Irina, go ahead.
Please.
Okay. Before I forget, I only wanted to say all the platforms that you already know are built around a language that we use that is LabVIEW. I'm sure that you know that. LabVIEW, because LabVIEW it is, for me, the language that I better can use. And it is, I think it's very nice for instrumentation, for acquisition and the development of the interfaces. I already were talking with the people from National Instrument, and they are happy to support this kind of project in order to give us, for example, licenses for LabVIEW in order to work with this, if you are interested. Yeah, that's all. Arina.
Irina Zelenova wants
Irina.
to say
Yeah.
something.
Thank you very much. Dear colleagues, I represent the Department of Computer Systems and Networks, and we have a number of courses that would benefit from a remote lab. I'd like to clarify whether is it possible to access boards with programmable logic chips such as FPGAs, please?
Irina.
Is my question clear?
Yes, Irina. Yes, it is.
Yeah, thank you very much.
Again, at ISEP, for the moment, we don't have, but you can access either FPGAs from Xilinx, more simple microcontrollers like Arduino, and for instance, with the boards with Xilinx, you also have access to the synthesis tools. So you develop your program, for instance, in Verilog or VHDL. You compile the code, you create the programming file, you send to the board. You have to pay attention to the pins that are connected to some external devices like switches and LEDs and keyboards, whatever. And then you can see in real time your program running on that particular FPGA. Okay. Labsland, the company that I mentioned, has a number of these remote labs installed all over the world. And I suggest you to see the ones that are installed at the University of Washington State in the United States, and that are run by a colleague named Raina Hussein. Okay, she's very keen on these remote labs. Okay, Irina, we can change the details by email if you want.
Super, thank you very much.
Thank you. Somebody want to say something? No, that one. Thank you very much, dear our partners, for your interest to cooperation with us. We will be interest for future, maybe projects, maybe exchange of ideas, maybe also for next possible webinars and discussions. And I hope that it will be very big impact for our university to join for your network, to use your opportunities. I think that we will be very glad to invite you in our university in future. And now, unfortunately, we have in political and war situation where it is very hardly and maybe make some risk to come to our city, but we try to survive. We try to work even in such situation that we have, and I hope that in future we will have possibility to invite you, and you will be able to come to our university to see our laboratories, to speak directly with our people, with real cases, etc. But current technologies makes possible to speak remotely, and it's very good for us because even in such hard times we have real possibility to cooperate, to involve students to your interesting installations, to use such opportunities for our laboratory studies. So it's very interesting and has a big perspective for our cooperation. So thank you very much all for your interest and for visiting this event.